Hello everyone, in this video we will be discussing linked allocation, which is one of the ways data can be stored in memory in data structures. Unlike contiguous allocation, where a single block of memory is used, linked allocation involves linking multiple blocks of memory together using pointers. Linked storage is a method of data storage that associates two pieces of data using pointers. Each data element is wrapped in an object normally called a node, which contains two parts, the data itself and a pointer to the next node or object in memory. To access a node, you need to know the memory address of the first node, and then you can traverse the linked list using the pointers. Linked lists are the most common application of linked allocation. They are used to implement lists, trees, and adjacency lists. In a linked list, each node contains data and a pointer to the next node in the list. The last node in the list has a null pointer to indicate the end of the list. One advantage of linked allocation is that it allows for dynamic memory allocation. Adding or removing elements from the linked list does not require copying all of the elements to new memory locations. Linked allocation also avoids the memory wastage problem seen in contiguous allocation. However, linked allocation does have its disadvantages as well. Unlike contiguous allocation, linked allocation does not have good cache locality. This can result in slower performance when accessing large amount of data. Also, allocation is not guaranteed as there may not be enough free memory to create a new node. In conclusion, linked allocation is a widely used method of data storage in data structures. It allows for dynamic memory allocation and can be used to implement various types of data structures. However, it does have its drawbacks, including slower performance and the possibility of not having enough free memory for allocation. When working with linked allocation, it's important to have a proper node representation. A node is essentially a container that holds both the data and a pointer to the next node in the linked list. In order to work with nodes effectively, it's important to have operations that allow you to construct new nodes and accesses their data and pointer values. The ability to construct new nodes is necessary when building a linked list from scratch or adding new elements to an existing list. Accessing the data values stored within a node is also an important operation as it allows you to retrieve and manipulate the information stored within the linked list. Similarly, accessing the next pointer is necessary for traversing the linked list and moving from one node to the next. Overall, having a well-defined node representation with clear operations for accessing and manipulating nodes is essential for working with linked allocation effectively. When it comes to implementing linked allocation, it's important to note that it's not as simple as contiguous allocation. It involves pointers in C, C++, or references in Java. But there is no memory wastage since nodes are created only when required. It's dynamic, which means that if more memory is required at runtime, a new node can be created. On the other hand, if a node is no longer needed, it can be deleted. Allocation is guaranteed as long as there are free blocks which can be claimed using nodes. When working with linked allocation, the operation for a node must include constructing a new node, accessing the data value, and accessing the next pointer. Overall, linked allocation is a powerful data structure that provides flexibility and scalability, making it a valuable tool for handling large and complex data sets.